factor there either. So nothing to factor in this one, but I will lock up that x plus 3, of course. Okay. Let's figure out our LCD and our restrictions. What do you see? What is our LCD?
Yeah, how do you find, I'm not understanding how you find the restriction.
Okay. So a restriction is because anything that makes any of these denominators undefined, and undefined means a denominator that equals 0, because you cannot have a denominator 0. You can't divide by 0. So anything that would make any of these denominators undefined is a restriction. Meaning when we find what x can be, anything that we already know x cannot be because it would make it undefined, we have to throw out. Okay? So the restriction just means anything that would make the denominator undefined, anything that would make the denominator equal 0. So what would make this denominator equal 0? Right. So if we say x equals 0 and then solve that, nothing to solve there, and we know x cannot be 0. What would make this one equal 0? Negative 3, right. Because then to find that, we do x plus 3 equals 0, and find that x equals negative 3. And we can check, if we plug in a negative 3, yeah, that would make that denominator 0. It's not that x can't be 0 because of this. Here, x could be 0 in this one, because that would make the denominator 3. But it can't be negative 3 because that would make the denominator 0. Okay? So our LCD is a conglomeration of all of our denominators. What do we see? Anything outside binomials is what we see first, right? Put that down, either the number and or variables. Any binomials? Do we see anything else? Not besides a 1, right? Okay. So our LCD is a product, a smush together of all, it represents all of our denominators. So anything that makes this LCD undefined equal to 0 will make at least one of our denominators equal to 0. Okay. So how many factors in our LCD?
2.
So we'll have 2 restrictions. First I'll weaponize it, and then my restrictions are anything that will make any of my denominators to 0, and I can use my LCD to find that. My restrictions are when x equals 0, x cannot equal 0. And my other one is x plus 3 cannot equal 0, which means x cannot equal negative 3. Either one of those numbers would make at least one of the expressions undefined. Okay. Times. Don't forget that times. Keep your operations really clear. Like when we do grouping, I see a lot of people leave out that middle plus when we're factoring grouping. Got to keep those there because they do have meaning. X plus 3 over 1 times x plus 3 over 1 times x plus 3 over 1. Okay. Now, if you had something that wasn't rational, you just wrote it in rational form, there's nothing to cancel out. But if you weren't fair to it, then this would stay 2 instead of 2x times x plus 3, and that would be totally wrong. Okay, so you're going to end up multiplying this, but there's nothing to cancel out. Okay. Here, cancel out the x, and here, cancel out the binomial. Lift what you have off, and in one nice flat equation, 2 times x plus 3 plus 3 times x plus 3 equals 2x times x. Oh, it looks like we may have a quadratic. We may end up with 2 solutions here. Okay. So let's kill the parentheses and start cleaning it up and think, oh, I may have to put it in standard form and go for 2 solutions. So let's see. So, I've got quadratic, right? So I got to put it in standard form. So I'm going to have to do minus 2x squared. And what happens when I do that?
That goes away.
Yeah. Think of like a scale with a big pile of fruit that's balanced on both sides. If you take an apple off of both sides, that scale still stays balanced. If you have the exact, here's an apple and an apple. You have the exact same thing, same sign, same thing on both sides. You remove it. It just cancels out. If you minus it here and minus it here, it's gone. So what we thought was quadratic at first actually turns out to be linear. Now what that gives me is standard form, but I don't need standard form for linear. I've got 9x plus 9 equals 0, but that, there's nothing to factor. Yeah, it looks like, there's a GCF, but that's not how you solve a linear. Okay? You want to solve for x, so it's 9x equals negative 9, and x equals negative 1. Subtract 9 from both sides, divide both sides by 9. Now, is that okay?
It's okay.
Yeah, does not violate with restrictions. Negative 1 would not make any of these numerators equal 0. So put it in set notation. We had a resulting linear polynomial equation with one solution, and the good solution for that linear polynomial was also a good solution for our original rational. Couple other varieties. I'm going to put 2 up here to finish off, so just give a last little variety of what we're looking at. You're going to see the same sort of variety in the homework and the test. Some of them may look slightly different, maybe a different type of factoring one or a different number of terms than another, but it all comes back to this. Even when you see things that look different in homework, take a breath, attack them in the same order, the same way. You may, like I said, have different factoring techniques or this or that, but it's going to be the same type of problem, the same order. So let's do x squared plus 6 over x plus 5 equals 2 times x plus 3 over x. Yes. This one seems to have more numbers and more mess. I don't want you to stop breathing when you see this. What you've already done is what you're going to do here is what you're going to do here. These are all the same. Remember, with the numerator, don't do anything to the numerator except lock it up if it needs to be. Don't distribute this. Or if you had something you could factor, don't factor it. The numerator, just leave it alone. Lock it up, walk away. Lock it up if necessary. Because you're just going to have to undo whatever work you do anyway later.
So it's like the x squared plus 6 on the denominator with factor.
If you could. And x squared plus 6, is that factorable? It's a binomial, perfect square, not perfect square, sum. Yeah. There's no GCF. It's not a difference of squares. If you have a binomial with no GCF and no difference of squares, you can't do anything to it. Yeah. So I wouldn't give you one with that as the denominator because everything I'll give you is going to be very clean and factorable. But yes, that if it were on the denominator, you would. It's in the numerator, and you don't. It's not factorable in this case, but even if it were, you wouldn't. Yeah. Does that answer your question? Was that? It's my LCD. Just a plain old x. Not x squared. X appears at most once in any one denominator. I see an x, I write an x. It only appears one time in any one set thing, so that's it. How many restrictions? Yeah. Just x cannot be 0. It can be anything else. There's only one asymptote in this related graph that would go through x equals 0. And the graph would go everywhere else. Okay. So, I got to weaponize my x and multiply times my LCD over 1, x over 1, all 3 terms, including that 5, which I put over 1.
Why do you have x over 3?
That's a good question. that I do not have a good answer for. Hence my love of white hat. Good. There. Nothing to get. This was not originally rational. There's nothing to cancel out. But if you didn't do this, it would just be 5, but it should be, as you see, 5x. Nothing to cancel out. Lift it off. Now I locked it up just to be very consistent, but there's nothing to distribute. There's no minus sign in front of it or anything to distribute, so I don't need those parentheses anymore. Just x squared plus 6 plus 5 times x equals, that all canceled out, so 2 times x plus 3. It looks like I'm probably going to have quadratic, right? I mean, I still got to distribute, but it doesn't look like any other quadratics are going to be created to cancel it out. So as I clean it up, I want to keep in mind I'm going to have to put it in standard form and factor to get my 2 solutions. So x squared. And I want to point this out too. Notice how the 6 is here and the 5x is here. There's a problem on your test. A lot of people did this. On the one where you have to kill the fractions and you get a quadratic trinomial. But the way the order was things, after you killed the fractions and moved the thing over to put it in standard form, a lot of people put it in the wrong order. And if you put your quadratic trinomial in the wrong order, your ACB will be wrong. A is your quadratic coefficient, B is your linear coefficient, C is your constant. If you wrote it as your quadratic, constant, linear, then your ACB was wrong. So check that problem, because a number of people did that, and if I made a note on there, okay, that makes a difference. So I'm going to go ahead and make sure this is in proper quadratic order. Quadratic, linear, constant, descending order of exponents. It's equal to 2x plus 6. It's still quadratic, so I'm going to move everything over. I'm going to minus 2x and what happens when I minus 6? Yeah, that's like an apple on each side of the scale, so I can just cancel that out. So minus 2x would give me x squared plus 3x equals 0. X squared. So, how am I going to factor this? Do I need to do my ACB?
You could do the x on x. What is it? Put them beside each other, can you?
Beside each other?
Yeah, like x plus, like the parentheses, the x and x.
Oh, like x plus x minus? Or?
Yeah.
No, because these are not conjugates, because this is not a difference of squares.
You can factor out an x.
You can factor out an x, yeah. This one actually, for some reason, does look confusing to a lot of people. You see a binomial, so on one hand, you want to think difference of squares. Well, it's not. Even if this were a subtraction, it's not perfect squares. If you've got an x squared here, that's great, but if there's an x here, that's not a square. Another thing is you see that x squared and that linear, and you want to think trinomial, you want to think ACB. Now, if this is not a trinomial, you have an A and a B, but you don't have a C. You can't do ACB if you only have an A and a B. Okay? So, what is the first thing you always do ever? GCF, and that applies here too. And this is what GCF. Once you take a GCF, you'll be like, oh, I don't have any. I'm good. Okay. Your brain kind of wants to do something else with that, but if you just follow that rule of GCF first, then you'll see that the square goes away, and you're good. Okay. So I factor out an x because they both share an x. I'm left with. So now I'm not solving for restrictions. I'm solving this quadratic polynomial. And the way to solve a quadratic polynomial is to put it in standard form, factor however it needs to be factored, and then each factor gives you a solution. So it's not x is not equal to, this is what x is equal to. So either x is equal to 0 or x is equal to -3. That is the 2 good solutions to this second degree, this quadratic polynomial equation. Are they good solutions to the original rational equation? Only one of them, right. I have to throw out the 0. That is a good solution to the polynomial, but not for the rational that we use to create that polynomial. So there were 2 solutions properly because this is quadratic, but to the original equation we have 1 solution. It's not no solution because we still have a good solution. Put it in a set notation and move ahead. Okay with that? Okay. Last one. This one's a little messier, but it's really just about factoring. That's first long tree-hating step. Factor, lock things up. This is you got to factor that. You know you have to factor it because it is not linear. Okay. So you got to think, okay, well, I know I have to factor it. It's not linear, so A equal 1, trinomial, quadratic, A equal 1. ACB, A equal 1, ACB, and I'm done. A lot of people wanted to do a grouping step. I saw this a lot. When A equals 1, ACB, and you're done. If you want to go ahead and use that ACB, your magic pair of numbers as a split middle and do grouping, that's fine, but what you're going to find if you really pay attention is if A equals 1 and you do the second grouping step, you're going to end up with the same numbers as your magic pair of numbers. Huh? Mathematically, it just takes you back to the same place you were. It's not wrong, but why make more work for yourself? You only have to do the grouping step if A is not equal to 1. If A equals 1, your magic pair of numbers are your constants. So notice on the test if you did that just to be more efficient. Okay, so that is not factorable, but I wouldn't do it even if it were. Now, if you have to do pencil and paper, you want to do your ACB cross, whatever, go off the page. And bring back just the nice, clean, factored form. That's, of course, a binomial times a binomial. Leave some room. That's not factorable, just lock it up. Leave some room. That's not factorable, just lock it up. And now I can see my LCD in front of me. My LCD consists of I see an x minus 3, and I see an x minus 4. Doesn't matter how many of them are or where they are. That's what I see, that's what I write, and then I just make sure, okay, none of them appear more than once in any one denominator, so we're good, no exponents. I weaponize it, put it over 1. How many restrictions will I have?
2.
Right. Either x minus 3 cannot be equal to 0, or x minus 4 cannot be equal to 0. Either one of those would make my LCD, and therefore at least one of my regular denominators undefined. X cannot be 3, x cannot be 4. Take my weaponized LCD, x minus 4, x minus 3, over 1. Everything cancels out on the bottom, and in this case, both cancel out on top. Here, the x minus 3 cancels out, leaving behind an x minus 4 on top. And here, x minus 4 cancels out, leaving behind an x minus 3 on top. Everything on everything on bottom transformed to 1, as it should. Lift down what I have. I had this numerator. I don't need parentheses because there was nothing to distribute, so I just lift it down, x squared minus 20. Be real careful about positives and negatives here. This is where a lot of mistakes are made. This is a subtraction sign, 3 times x minus 4. So you're going to be distributing a negative 3. Then equals 5 times x minus 3. I can see that's quadratic, and it looks like it's going to stay quadratic. So I just start cleaning it up with an eye to putting it in standard form. Minus 20 minus 3x plus 12. Be very careful. You're distributing a negative 3. That makes a plus 12. I make sure that it is in quadratic order, and then I'll bring everything over. So x squared minus 3x, and then minus 8. A, B, C. It's equal to 5x minus 15. So I'm going to minus 5x on both sides and add 15 to both sides in order to get everyone off the lawn and into the house. So minus 5 on both sides makes this. And plus 15 will cancel it out here and make this plus 7. Just using my addition property to move everybody in. Add the opposite to cancel it out. Do the same thing on the other side. I see I'm in standard form. It is a quadratic, so I'm going to have two solutions. It's in standard form, so I have to solve it by factoring. It's a quadratic trinomial, a equal 1. A equal 1, so ACB, and I'm done. I will give me two binomials. A equal 1, so I have naked x's. Positive c, but negative b means I have a sign pattern of negative, negative. Make your ACB cross, if you need to, with a c of 7 and a b of negative 8. Two signs are both negative. Remember, it's all multiplication, 1 times 7. So that gives a positive 7 and a negative 8. And I don't have to do a group, A is 1, so I'm done. I don't have to do a grouping step. If I did do this, if I made this 1x and 7x, negative 1x and negative 7x, and wrote a 4 term and grouped it, you're going to get right back to here. Okay? So nothing wrong with it, but why make your life more difficult? Why make your life more work? Okay? Okay? Here's my 2 factors. Each one gives me a solution.
1 7.
Uh-huh. Before I put them in set notation and move on, are they good?
Yeah.
Yes, those are the 2 good solutions to this polynomial equation, and they also are good for the original rational that we created the polynomial equation from. Put them both in set notation, comma separated list, and you're done.
So let's say the denominator was factorable, you wouldn't touch it until you get the denominator like out the way, and then you'll simplify the equation.
If the numerator was factorable, right, don't factor it.
You just do it towards the end and you get there.
Right, because once you add and subtract other things to it, just like when you're simplifying an expression, it will change. Yeah, and a lot of times you have to then undo the factoring you did. If you're going to have to factor, you will, but after you invite everybody else into the party. Yeah. Yes?
So why put the x on those numbers again?
I'm sorry?
Why don't you put the x on the negative 1 and the negative 7?
Over here?
Yeah.
Because since a equals 1, then that magic pair of numbers are my constants. So I'm done. When a equals 1, ACB, and I'm done. And my answer is x minus 1, x minus 7. Huh? Now, if I was going to do my grouping step, if a is not equal to 1, I need to do my grouping step. Even if a is 1, you can still do the grouping step. I would put an x here, and negative x and negative 7x, and I'd write my 4-term polynomial and group. When you finish that, you're going to end up with x minus 1, x minus 7 anyway. Yeah. So there's no reason to do it's mathematically not incorrect, but there's no reason to do it. You're going to end up with these 2 numbers anyway. When a equals 1 and your x squared is then your x squared is naked, then so are your x's, and so that magic pair of numbers gives you your constants. You only have to do the grouping step if you also have to figure out the coefficients in front of x, because if x squared is not naked, then neither are those x's. So you need that extra step to find what are those coefficients. And grouping this would get you right back here. It's not a problem. It's just not efficient. Okay? All right. So like I said, on homework, which we'll post by 10 or 15 after latest, okay, you'll see a variety of these problems. They may look slightly different. There might be slightly different factoring things you have to do, et cetera, et cetera. But it is all exactly the same process. It all gets you there. So we don't have a lot of time, but I do want to introduce at least the one kind of problem we're going to do. You will have a few of those to practice on homework, and I'll include it on the test, but I'll keep in mind that we're right at the end here. But you do want to practice them. So let's look on the worksheet. These word problems, like I said, set aside. We're going to come back to that later before the final. But right here, this section, the solve equation for a specified variable. This list right here, like I said, you'll see on homework and 1 or 2 on the test. So let me show you how.
Okay.
Huh?
This test?
The test on Tuesday?
Yeah.
Possibly, yeah. I know we're rushed at the end, so I'm going to take that into consideration, but you will see a couple of them on homework. Okay? Now, it's not any new rules. It looks funny to your brain because it is all letters instead of numbers. But all the rules you already use are the same. Okay? So, with the exception of one rule. Okay? If you have, and this rule actually makes things easier. It's not really different. It's just a way, it's like a shortcut. Okay? And it's a shortcut you could use sometimes with these, but I don't want to mess you up with those. Okay? That method, stay with that method when you're solving equations with numbers. But sometimes with letters, it's a little easier to see this shortcut can be very helpful. So if you have a rational expression, let's just call it A over B, and it is equal to another rational expression. Now, there's no other rational expressions added or subtracted to this. Yeah, this might be a big, ugly rational expression here or there with binomials and pluses, but this is not a rational plus or minus another rational. It's one rational on the left, one rational bar on the right. Okay? This is a ratio is equal to another ratio. Okay? Ratio or rational. Okay? And when you have a ratio equal to a ratio, one rational bar on the left, one rational bar on the right, then you have what's called a proportion. Okay? Now, A proportion, the nice thing about a proportion is when you have this situation, this rule applies. Cross products, cross meaning diagonal, products meaning multiply, cross products are equal. So this is a shortcut to bypass having to do you can still do this with LCD and then LCD over 1, weaponize it, cancel it out. But if you see 1 ratio and 1 ratio, cross products is like a shortcut to make that happen, to flatten it out in 1 step rather than 2 or 3. Cross products are equal mean that cross products just means multiply diagonally. So this is one cross product, and it's equal to the other cross product. And it doesn't matter which one you put on which side. Okay? A times D, or AD, A times D is one cross product, and it is equal to the other cross product, B times C. BC equals AD, same thing. Okay? So you can see how this would flatten it out in 1 step. Okay? So let's look at number 3 from that handout. Like I said, we're going to look at 3 and 7, hopefully 7. 3 and 7. And the other ones from that section, 1 through 8, consider those extra practice. Besides the homework, extra test practice, I'll post solutions for them. So here we have a formula. P equals A, use of capitals or lowercase as given, 1 plus A over 1 plus RT. Now this is a formula. We can't solve it for a number. There aren't any numbers involved. There may be one, like here 1, but there's not enough. You're not solving for a number like x equals a number. Okay? But what you can say is this is currently solved for P. Huh? That means P is all by itself on the left and everything else is on the right. It's solved for P. What we want to do is solve it for a different letter. So we're going to say take this formula and solve it for T. Okay? Now all that means is you're going to have to move things around so that T is alone on the left and everything else is on the right. Now you're going to do so with rules you already know. No new rules involved in this. It's confusing at first because you're dealing with letters instead of numbers and your brain has to adjust to that. Now, I've got a denominator here. Now I'm going to rewrite that. Is this a ratio equal to a ratio? Is this a single rational on the right? Yeah, it doesn't matter if something is plus or minus in the numerator or denominator. That's a single rational bar. That's one ratio. Is this a ratio on the left? Can you make it one? Yeah. Just write it over 1. Now it is equal to A over 1 plus RT. Now I'm going to target that T, but first I want to flatten this out. Before you target your thing, go ahead and flatten it out. Now, because this is a proportion, I can use cross products. I don't have to worry about finding my LCD. So, any numerators or denominators that have some pluses or minuses, though, do lock them up. That changes everything. And then I'm going to flatten it out with my cross products. On one side, I'll put 1A. Or it could go, it doesn't matter which side is which. And then the other cross product is capital P, and this is why the parentheses are so important. It's not P times 1, it's P times 1 plus RT. Parentheses are important. That P is multiplied times that entire thing. Okay. Ooh, nice and flat. Okay. Cross products, flatten it out. Now I need to go back. I'm looking to solve it for T. My goal here is the T. Okay? So my goal is to get that T all alone. So first thing I'm going to have to do is kill some parentheses. I got to free the T. Okay? And then I got to do anything to move stuff over to the other side. Using the same properties of equality I already know. Add the opposite, divide away the coefficient. Okay? So first I got to free the T. So first I'm going to have to, if I've got any parentheses, I got to kill them with distribution. Okay. So 1A, I can just write that as an A. And so this becomes P times 1. Well, that's just P. Plus P times RT. How do I write that? PR, right, yeah.